Hello class, so in this video we're going to be talking about two tests because they're kind of related. The ratio test and the root test. This is going to be the last video talking about convergence tests. So these are the 7th and 8th ones that I'll be going over. Alright, so the ratio test is this. So if we have some sequence and then take the limit as n approaches infinity of a sub n plus 1 over a sub n, absolute value that, and we get a limit. If that limit is less than 1, then this thing converges absolutely. Converges absolutely means basically this. If we take the absolute value and that converges, then that means this thing converges absolutely, which means it converges. Alright, anyway, then if the limit is greater than 1, then we get that the limit diverges. If the limit equals 1, then we can't tell. So root test, kind of similar, except we're taking the nth root of the absolute value of some sequence. Again, looking at that limit. And if the limit, again, less than 1, converges absolutely. Greater than 1, diverges. Equals 1, don't know, try something else. So the question is, why do these make sense? Well, if L is less than 1, that means the absolute value of the ratio between subsequent terms. So each term as it goes on, that ratio is becoming small. It's getting less than 1. And yeah, so that means it's going to be fast enough to converge. It's small, getting smaller fast enough. Alright, and then if the limit is greater than 1, basically that means divergence test, this thing is going to get too big. And if it equals, why did I put 0? I meant 1. And if it equals 1, then, well, who knows? In other words, we gotta try something else. So this is generally pretty powerful test, except when you don't know. Okay, so the root test, similar idea. That means that if L is less than 1, we have the nth root of the absolute value of something getting really small. Same idea, just something getting smaller and smaller and smaller and smaller. Versus if that doesn't happen, if this is greater than 1, then divergence test, this limit's not going to approach 0. And then, yet again, if L equals 1, nobody knows, gotta try another test. So, the question might be, when do we use them? So, for ratio tests, if you have factorials or n as an exponent, it's probably a good idea to try it. And if a root test, if you can easily make an nth root, so if you have n as an exponent, then that might be a good thing to try, because that may make things a little bit easier. So let's try working with these and see how they go. Okay, so we're going to use a ratio test on these. So let's take the limit as n approaches infinity of the absolute value of a sub n plus 1. So that's going to be 3 to the power of n plus 1 all over n plus 1 factorial, all divided by 3 to the n over n factorial. Okay, let's simplify this thing algebraically, and then you'll see why factorials make this really nice. So limit as n approaches infinity of, now we can make this a bit smaller. So this is 3 to the n times 3. I'm just going to write it that way. And then instead of n plus 1 factorial, I'm going to write this as n plus 1 times n factorial. Then multiply reciprocal. Three to the n. Alright, let's see what nice thing happens here. So 3 to the n will divide with 3 to the n. N factorial will divide with n factorial. And then what we have left is the limit as n approaches infinity of the absolute value of 3 over n plus 1. That approaches 0. Therefore, and that's also less than 1. So, therefore, by ratio test, this thing is going to converge. Oops. And yeah, so notice that in all of these videos, if you've watched the entire thing, I've been writing the whole series converges. You want to get into the habit of that, especially when you're doing a whole bunch of different problems and you're doing that on a test or something, just because you want to make sure that your reader knows exactly what you're referring to. It seems redundant, and I know it takes time, but just do it. It's better to communicate that way. All right, next one. Let's try this, see how that goes. All right. Let's try that same thing. The limit as n approaches infinity of... Okay, so n plus 1 is going to give us... Let's see, so that's n plus 1 squared, all divided by 2. Okay, so be careful with this. The 2 is applied to the n, right? So that's 2n plus 1 plus 1 factorial, all divided by the original thing. This is going to be fun. You might see why this is going to suck a little bit soon. Alright, so the limit as n approaches infinity of... Let's see, so that'll be n squared plus 2n plus 1, all divided by... Alright, so let's work on this thing, simplify it a little bit first. So that'll be 2n plus 3 plus 2n plus 1, oh, factorial, divided by n squared. Alright. Limit as n approaches infinity of... Let's just move the n squareds together. They're not going to go away, as you can probably tell. And it is just going to be... Actually, I'm going to write the denominator first, because it's going to get big. Okay, 2n plus 3 times 2n plus 2. And then we get, finally, this one, 2n plus 1 factorial. And then the numerator is 2n plus 1 factorial. But this is worth it because something nice happens, which is... that will divide with that. And then just looking at this, you can tell then that the denominator is going to be a lot bigger than the numerator, so you can tell that this is going to be less than 1. Therefore, by ratio test, this summation converges. All right, so just writing that whole thing out, converges. All right. So we haven't seen what the diverges yet, but basically if you just evaluate the limit, see if the thing becomes greater than 1 or not. All right, next one, root test. Let's look at how this works. Okay, so let's see. This is a sub n. So let's rewrite this actually. A sub n could be the same thing as saying 2 over n minus 1 all to the power of n, right? Because they each have that power. So let's find the limit as n approaches infinity of the nth root of that. let's see, n minus 1? Yeah, n minus 1 to the nth power. All right. And then let's see. So nice thing happens here. This and this will, well, they're inverses of each other, so that's gone. And what's left is the limit as n approaches infinity of 2 over, oh, and this was supposed to technically be absolute value, but, you know, it didn't matter in this case. Okay, so that's going to converge to 0, which is less than 1. Therefore, by this time, the root test, this summation will converge. All right, so limits, gotta know them, gotta practice them. Just a lot of algebra here. So if you need to practice algebra, definitely practice that. That'll be very important in all of calculus, but especially this kind of stuff when you're testing all these things, especially if you look at this. If you notice those algebraic patterns, it makes things a lot easier. All right, so that'll be the end of this, and hopefully that was helpful, and I'll see you in the next video.